All right, let's do some of the problems from the textbook that are a little different, that look a little different than the ones that I did. So we're going to start with 165. Again, the arc length here, we should be able to calculate this exactly because it's a line. But let's just get some practice visualizing and just reaffirming some concepts. So the line y equals 5x. Ooh, OpenSnacks is going to behave like that today, are you? So the line is just y equals 5x from 0 to 2. So you have this steep line from 0 to 2. So this is the point, 2 comma 10. So with geometry, bless me by the way, with geometry, we know the arc length is exactly just the square root of 2 squared plus 10 squared, square root of 104, which can be simplified as 2 root 26. We know the arc length already, but let's use calculus and make sure it's right. So calculus says the arc length is going to be the integral from a to b of the square root of 1 plus the derivative squared. What's the derivative of this function? Well, it's just 5. So that's going to be integral from 0 to 2. This becomes the square root of 26. Oh, that's a good sign. Dx. What's the antiderivative of this? October. Why are you pawing at my computer screen? Huh? What are you doing? He was pawing at my face on my second monitor. She knows. She knows. All right. She doesn't know. I think she's... I don't think... Yeah, anyway. So this antiderivative is going to be the square root of 26 times x. Evaluated from 0 to 2. Plug in 2, we get 2 root 26. Plug in 0, we get 0. And whichever way you get, we see that our answers line up exactly. There it is. We could do the same sort of thing with some other shapes as well, I'm pretty sure. But that's this one. So 165 is the first one. October is sitting on the second number, but I think it's 187. Find the lengths of the functions of y over the given interval. If you cannot evaluate exactly, use technology to approximate this. Chose this one because of the trig function, the tangent. So we want x equals tangent of y. From y equals 0 to y equals 3/4. We can draw this by hand. Remember, tangent looks like this, and it repeats forever. So this is going to be x equals tangent of y. That'll look like this. And again, it repeats forever. To the top and the bottom. I'm not going to draw the other ones. And remember, this is not a function of x. It fails the vertical line test, but it is a function of y. Because each y value only has a single x. So we'll just write this as this. Again, and on this domain, this is the same thing as arctangent. Okay. Well, starting at y equals 0, we're going to y equals 3/4. Wait, let me make sure that there's no shenanigans. This asymptote is important. That pi over 2. Because the tangent of pi over 2 is undefined. Is 3/4 less than pi over 2? Well, pi is about 3. 3.1. So yeah, this is like 1.5. So, all right, good. We're not running into any weird, funny business. We're just looking at the arc length on like this interval. We don't have to worry about anything weird. If it was going all the way up to pi over 2, it'd basically be infinity. But no funny business here. So what do we have? We just set up the integral with the formula. We get the integral. Y, again, this is in terms of y. Y is going from 0 to 3/4. Square root of 1 plus the derivative with respect to y squared dy. What's the derivative of x with respect to y? What's the derivative of tangent? Secant squared of y. The question is, oh, we're squaring this, by the way. Question is this able to be done by hand? Well, we could rewrite it a little bit. We could factor out the secants and write things in terms of cosines. And yeah, we can't do this yet. We'll use a calculator to evaluate our answer. Okay, because 1 plus tangent squared is something, but we have 1 plus secant to the 4th. And there might be some real fancy stuff that you can do with power reducing formulas. That's not something that you are expected to be able to do right now. But at a guess, if we were doing this with chapter 3 stuff, that's what I would attempt. Some power reducing formulas, but the fact that it's secant to the 4th means that's kind of tricky business, but who knows, it might work. But what matters is that you don't need to know. Okay, so we got this. We have the integral from 0 3/4 of square root of 1 plus secant x to the 4th dx. And again, we should be able to get a little approximation of this. Oops, x is tangent of y. So again, you see that graph as I was talking about before. And we're only looking from 0, from y equals 0 to y equals 3/4. So when y is 3/4, the x coordinate is tangent of 3/4. So let's just zoom in on this and get a little approximation and see how our approximation kind of works with what we expect it to be. Shall we? So we can approximate this just by a line, right? And if we do it by a line, well, the x distance is tangent of 3/4 squared, whatever that is. I always miss the caret when I have my keyboard written like this. And the y distance is 3/4. Is this close to our approximation? 1.2? 1.195? Yeah, that's close. Our actual answer, which I didn't write down, is about 1.201. This is arc length, so it'll just be in units. It's a length, meters, centimeters, inches, miles, whatever. And our approximation, if we used a line, was 1.196. That's a pretty good approximation here. As a side note, a lot of the approximations we've done in this section have been really good because we're just looking at like really kind of boring pieces. If we were looking at, the sine of x for like 5 periods, we couldn't easily approximate that. That would, well, actually, yeah, we could. We could. But it's not always this easy to approximate. Let's do the last one. 195. Goodbye, October. Oh, don't scroll that much. Find the surface area of the volume generated when the following curves revolve around the x-axis. So we're looking at under the graph, and 195 says y is going to be the square root of 4 minus x squared. Okay, so we got a semicircle situation. X equals 0 to x equals 2. So again, graphically, what's happening? This is a circle of, oh, wait a minute. I just realized something from earlier. It wouldn't have been it would not have been an ellipse back here. Where was it? I don't remember how far back I went. With the 81? Oh, it is that y to the 4th though. Yeah, if you factored out the 81, it'd be in the square root. And you get 1 over 81 plus y to the 4th. Yeah, that's not a circle at all. You're gonna get into some If this were y squared, we could do it. Radius, circle of radius 1/9. Oh, well. Anyway, made me think about it. So again, yeah, this is y squared equals 4 minus x squared. This is x squared plus y squared equals 4. That's centered circle on the origin, radius 2. That's where that's coming from. Okay, you don't need that, but that's just where it's coming from if you want to recognize that. We're rotating it about the x-axis. Oh, so we should already know the answer. All right, what is this solid when it's rotated around the x-axis? It's a sphere. We should just get the surface area of a sphere of radius 2. But let's do it using what we know. Rotating it around the x-axis, so using the formula, it's going to be 2 pi times the integral. X is going from, okay, sorry, hemisphere, right? Because we're only looking at this side. So integral from 0 to 2 of the function, that's our function, times the square root of 1 plus its derivative squared. What is the derivative? Well, it's going to take a bit of work. So let's rewrite y real quick. It's 4 minus x squared to the 1/2. So we can use the power rule with the chain rule. Bring down the exponent, leave the inside alone, subtract an exponent. Multiply by the derivative of the inside. And again, leave that inside alone, and this is what we get. The 2 cancels with the 1/2. And we're left with negative. I think there's only an x on top. And the bottom is the square root of 4 minus x squared. I believe that's what we have here. Ooh, this is looking like it's going to be an interesting integral. Which again, is why I chose this problem. 2's cancel, there's an x on top, it's negative. Yep, that looks good. Checking my answer in my head. And we need to square this. Right, it's always the derivative squared for these problems. Now let's simplify and see what we get. Let's see if we can do this by hand. I'm leaning towards no, but it might be a yes. Square root of 4 minus x squared times the square root of 1 plus x squared over 4 minus x squared. Yeah, this is looking pretty doomed. But let's work with it. Let's work with it. So if we distribute this 4 minus x squared in, we get some cancellation. 4 minus x squared times 1 is 4 minus x squared. 4 minus x squared times the other fraction cancels, and we get, oh! Sorry, I got a little excited because look at this. Look at that. We know what this is. Cancellation. It simplifies the inside. The integrand simplifies just to the square root of 4, which is 2. What's the antiderivative of 2 with respect to x? 2x from 0 to 2. We get 4 pi. And then when x is 2, you get 8 pi units squared. What's the surface area of a sphere? I don't remember the formula. 4 pi r squared. Oh. Wait. Oh, we wanted hemisphere. Hemisphere. Because if r is 2, right, we get 16 pi. But we want half of that. So 8 pi is right. Scared me for a little bit. This is our hemisphere surface area. I don't know why they don't call it a semisphere. A semisphere? Anyone know? You should tell me. All right. That's it for this video. Let me know if you have questions. I think I didn't see any homework problems that looked any wackier than this, but if you see them, ask. All right. Bye-bye.